Hello everyone. In this video, I'm going to go over how to predict the weather using pressure. So with air pressure, you can actually predict three things on a weather map. You can predict the wind direction a location is going to get. You can predict how fast the wind will be in that location. And you can predict how likely storms will occur in that area. So air pressure is a really powerful tool that you should always pay attention to when you're looking at a weather map because it's going to help you determine a lot of different factors. All right, so before we get started, I want to make sure that you know notes are really important while watching this video. I recommend you either get out a science notebook to take notes in, or you open up a Google Doc and take notes in that Google document. The reason for this is this unit, we are going to have an end of unit test and we are not going to do a project. We also are going to let you use your notes on the test. There is going to be a time limit most likely, but you are still going to be allowed to look at your notes on the test. So it's going to be very helpful for you if you have good notes. So I very strongly recommend you keep your notes organized and you take notes on this video because this video will be very helpful for the test because I'm going to go over how to predict weather, which is a decent portion of the final assessment. So feel free to pause the video here and make sure you are ready to take notes before continuing. All right, so we're going to start by going over things that should hopefully be review for you. However, this review slide is super important. If you do not have high pressure moves toward low pressure in your notes yet, you should write it down. Maybe even draw a picture of high pressure and then an arrow toward low pressure. That is a major concept for this unit, and it will be very helpful to know that when you're taking the test. So if you don't have this written down yet, high pressure moves toward low pressure, please write it down. All right, so just to review a little bit, Earth's surface gets heated unevenly. This is because we have different materials on Earth. For example, land gets heated up faster than the ocean and other factors like that. Also, the atmosphere doesn't always get heated up evenly. And as a result of this unequal heating, we get areas of high pressure and areas of low pressure. This is what causes wind, and this is what causes air to move. So high pressure areas, air is always going to move away from high pressure areas and toward low pressure areas. So a really easy way to remember this is high to low, right? So you draw an H and then you draw an arrow toward low because high pressure moves away, air moves away from high pressure and it moves toward low pressure. All right, so we're going to do a quick practice problem that's going to help us remember and practice this concept of high pressure moving toward low pressure. So I want you to look at this map and I want you to try to determine in what direction do you expect air to move across the United States. So pause me and answer the question and then unpause me for the answer. All right, so hopefully you've made a prediction about what direction the air is moving in. And I would say I would accept two answers for this question. So let me pull out an arrow to help out. All right, so the first direction that I would accept as correct is you could say the air direction will be moving south. This is because you have high pressure in the south and low pressure. You have high pressure in the north and low pressure in the south. So I would accept you saying air is going to move south. You also have high pressure areas in the east over here. So I would also accept the answer of air is going to move southwest. This is because air is going to come from the east and it's going to come from the north and move toward the southwestern United States. So overall, I think south or southwest is a good answer for this. All right. So the next thing I want to talk about is something that will actually make this a little more complicated, but I think it's really important. So I'm sorry if this gets a little confusing, but I promise if you listen all the way through, it should hopefully make sense at the end. Air does not actually always move in a straight line. It would be really nice if it did. It would probably be easier to predict the weather. But sadly, air actually tends to move more in a circular motion than in a straight path. So earlier this week, Mrs. Smith showed you or Mrs. Smith's audio presentation showed you this picture. It showed that high pressure zones, air tends to move in a clockwise pattern around it. And at low pressure zones, air tends to move in a counterclockwise direction. If you don't have this in your notes yet, I strongly recommend you add this picture to your notes. If you're taking your notes online, open up this presentation, copy it, and then paste it into your notes. But I do think knowing that high pressure zones move clockwise and low pressure zones move counterclockwise is a very important thing to have in your notes. All right, so we're going to start by watching a little video that goes over some of the complexities of predicting wind direction. And then we're going to look at some examples together as a class.
All right, so this topic is, how do you know the direction of wind on a weather map? So a lot of times you see the high and the low pressure symbols on the weather map. So you'll see a high pressure like this, and you'll see a low pressure like this on a weather map. How do you know, like if you were standing at a certain point, like somewhere in here, how do you know basically the direction that the wind would be at different points on this weather map?
So right now, we've been teaching you high moves to low. So we would just draw an arrow that goes from high to low.
How do you know? Well, first of all, we need to understand the basic nature here of what these two systems want to do. High pressure always wants to move towards low pressure. It's kind of like saying something a ball always wants to roll downhill. So the high pressure wants to go straight to the low pressure. That's what it wants to do. But the Earth is spinning, okay? So it can't go directly there. It has to go in a cyclical fashion. So this is getting into the concept of vectors with physics. Basically, around a high pressure, you have something called an isobar, okay? So there's an isobar. And you have them around low pressure too. And these are lines of equal pressure.
And I'll explain this after he goes through it himself. I think I can explain it a little bit more simply than he does.
Okay, and so as these go out, each one of these lines has equal pressure on it. So it could be 1,000 millibars, 900 whatever it is. It gets higher as it goes up, so 900, 1,000, whatever. Same thing around the low pressure. So they make these rings. They're not exactly circular or concentric, but they're somewhat circular, okay?
All right, so these isobars that he is drawing are sometimes shown on the weather map, and their purpose is to show you when does pressure change. So for example, when you're inside this smallest circle right here around the H, that is where the pressure is the highest. And then as you move away from the high pressure zone, once you cross this first line, the pressure decreases a little bit. And then all of this area has pretty much the same pressure until you get further away from the H. And when you cross the next line, pressure decreases again. Then when I get over here, I am somewhere between the high and low pressure, right? And then as I move toward the low pressure, pressure continues to decrease every time I pass a line. And then once I pass this last line and I'm in the low pressure zone, that is where the pressure is the lowest. So these lines just represent when is pressure changing.
The tighter that these are, it's kind of like, think about these like, like a map, like altitude. If these are tight, like between each other, that means that there's a lot of pressure difference and the wind is pretty strong in here. So what happens is high pressures are going to spin clockwise. I'm talking about northern hemisphere, but clockwise, okay? So high pressure is going to spin clockwise. So the air is going to want to spin in this clockwise direction like this. So this is vectors. And
all right, so I'm going to stop him here.
It's going to spin
just because he's going to draw arrows all the way around on each of the isobars now. And we don't need to watch him do all of that. But I do think he makes a really good point here that high pressure spins clockwise and low pressure areas spin the opposite way. So they spin counterclockwise. So if I skip forward in the video, you can see he drew all the high pressure ones going in circles. And then he does it for the low pressure, and he draws all of them in circles. And this is where we get to answer this question of how can you like more accurately determine the direction wind is going on a weather map. So if we look at this high pressure zone, you can see that if you're above a high pressure zone, these arrows are pointing east. So when you're above a high pressure zone, since wind moves clockwise around a high pressure zone, you can assume that the wind is going to move east if you're above a high pressure zone. If you were below a high pressure zone, you would see that the arrows are moving to the west, so you'd expect the wind to be moving west. Meanwhile, if you're closer to a low pressure zone, if you're above the low pressure zone, you can see that wind will be moving west. And if you're below the low pressure zone, you can see that pressure will be moving east. Now, if we go back to these locations that the video maker drew on the map, you can see that since these locations are kind of to the east of the high pressure zone and to the west of the low pressure zone, when you're east of a high pressure zone, you're going to have southern winds. And when you're west of a low pressure zone, you will also have southern winds. You can see these from the arrows that he drew. So you would expect the wind to be moving south, maybe southwest. But you can kind of see that when you draw these arrows around the low and high pressure zones, you get a better idea of where the wind direction will be. So this is kind of just a simple way to think about it. I know it's more complicated than saying high pressure moves to low pressure, but this is more accurate. And before you start to panic and say, wait, but you guys have been telling us about these straight lines the whole time, I don't want you to think that we've been lying to you or that what you know so far is not true, because it is. If you are given a weather map like this, yes, wind is generally moving in a cyclical or circular pattern. However, overall, the air in this high pressure zone is going to be moving toward the low pressure zone. So what this means is, even if they're not moving in a completely straight line, wind and air is going to slowly move in the east in this scenario. So it's going to slowly move east. So you can still draw these straight arrows, and it is still true that overall air is moving in that direction. So please don't think that's not true. High pressure does move towards low pressure. All right, so on these next few slides, I'm going to go over specifically how to predict wind direction, wind speed, and how stormy a location will be. So I strongly recommend you get your notes out and you write down what I put on these slides. So at any point, if you need time to write down what's on the slide, feel free to pause the video and write down what I'm going over. So we're going to start with wind direction. And I kind of went over this recently, but you can predict wind direction based on where it is relative to high and low pressure areas. I need to copy this. All right. So just to reiterate from earlier, if you are near a low pressure zone, I would recommend drawing arrows that are going in the counterclockwise direction around it. And then you would just look at where your location is relative to the low pressure zone. So for example, if your location is east or to the right of a low pressure zone, you could put the arrows that go around it down, and then you could see that at this location, you would expect the wind to be north or northwest. If you were to put it somewhere else, like south of the location, if your location that you're trying to predict the weather for is south of a low pressure zone, you could predict that the wind is going to move north or northeast. And then the trick also works for high pressure zones, except you're going to do clockwise instead of counterclockwise. So once you draw arrows around your high pressure system, if your location is close to that high pressure system, you can use these arrows to help you guess the wind direction. Let's say, however, that you are not close to a pressure zone, and instead you're in between two pressure zones. So let's say your location is right here, right in between an H and an L. If that's the case, I would recommend just saying that the wind direction is in the direction of the low pressure zone. So since we know air moves from high to low, If you're in between those two locations, I think it's easiest, since it's very hard to predict in this scenario, to say that wind is going to move toward the east, just because you know it's going to move away from the high and toward the low. So I strongly recommend writing these 3 bullet points into your notes. Feel free to pause the video now and then unpause it when you're ready to move on to wind speed. All right, so wind direction was definitely the hardest thing to predict. Wind speed and chance of storms are actually a lot easier to predict. You can determine if wind speed is going to be high or low by comparing the difference in pressure between 2 areas. But in summary, these are the 3 things that I recommend you put into your notes. If you are at a location that is very close to a low pressure area, you should predict wind to be strong. If you are at a location that is very close to a high pressure area, you should predict the wind to be weak. And then lastly, if your location is somewhere between a high and a low pressure area, you should expect the wind to be moderate. And the reason for this is low pressure areas pull in air. Since air is moving toward a low pressure area, the wind is going to be strong because of all that incoming air. High pressure areas push air away. Air leaves these locations. And as a result, you shouldn't expect very much wind. You might have a light breeze, but that's it. And if you're in between a high and low pressure area, the wind is going to be moderate as it moves away from the high pressure area and into the low pressure area. All right, so feel free to pause the video and finish writing down these 3 bullet points. Unpause when you're ready to move to the next slide. All right, so the last thing we're going to discuss is chance of storms. So I tried to summarize this one. So I have the explanation on this slide and the summary on the next slide. But the big idea is, you can see from this picture, high pressure areas push air away. And as a result, air that was up high at a higher altitude is going to sink down to replace that air. This pulls moisture out of the sky and leaves you with dry weather. Low pressure areas kind of do the opposite. Air comes into low pressure areas, and as a result, the air that already existed in that low pressure area needs to rise up to make room for that new incoming air. And when that old air rises up, it brings up moisture with it. And then as a result, you get a lot of moisture up in the sky, and that creates precipitation, which can be rain, snow, sleet, or hail, depending on the temperature. So moving to the next slide, this is what I want you to write down, and this is the big idea. In low pressure areas, you should expect wind, strong wind, right? And you should expect storms because there's a lot of rain. So if you have a lot of rain and it's windy, that's how storms start, right? So if you're in a low pressure area, you can expect a storm to possibly occur. That's a good situation for a storm to happen. Meanwhile, if you're in a high pressure area, it's not going to be very windy and the air is going to be very dry. And as a result, you shouldn't expect storms when you're in a high pressure area. All right, so that is all of the notes I have for you on predicting the weather using pressure. But I do want to check your understanding. So there should be a Kahoot in the classwork tab if you go to Google Classroom. So please go to Google Classroom and complete the Kahoot. Try to compete against your peers. The faster you answer questions and the more correct answers you get, the higher your score will be. But this is also going to help me and the other teachers understand, do we need to review a concept, or are you understanding what we're going over? All right, thank you for watching my video. Please contact your science teacher if you have any questions. Thanks, bye.